This is chapter 7.2, laws of exponents. We're now dividing monomials. Example 1, we have a to the 6th divided by a to the 4th. So there's 6 a's on top, there's 4 on the bottom. A divided by a is 1, 1, 1, 1. We say cancel a lot, but it's not actually canceling, it's simplifying to a 1. So we're left with a squared over 1, which is just a squared. Notice there's a pattern. There's 6 on top, there's 4 on the bottom, we get 2. Instead of writing them out and simplifying every single time, what we could have done is just subtract. So we have a rule. This is a quotient because it's division, and we are using the powers. So it's called quotient of powers rule. It says to divide to divide 2 powers with the same base subtract the exponents. So if we're going to divide any 2 powers with the same base, they both have to have a on the bottom. If they both don't have a, then we can't do it. Okay? So, for example, let's say we have a to the m over a to the p. Well, then that's just a to the m minus p. Okay? Saying that m and p are integers. So let's try it in example 2a and 2b. It's the same base. So we keep the 2, and it's 6 minus 4, which is just 2. So your answer is 4. 10 to the 9th over 10 to the 7th is 10 to the 9 minus 7, which is 10 to the 2nd, which is 100. Okay? So let's keep going. Example 3. This is a 1. I'd put a 1 there. I would put a 1 there. 3 minus 1 is 2. Now, do you have to write this middle step every time? No. But it will help you when you have ones like this. All right, x to the a, x to the first is x to the a minus 1. There's nothing more you can do with that. X to the a plus b minus c. That's all you can do with it. All right, example 4a, same thing. We have a negative 4 and a 2. They do not have the same base, but what is negative 4 divided by 2? That is a negative 2. So those are just numbers. You deal with them like you normally would. Now we have the same bases again. 2 minus 1 is 1. 5 minus 3 is 2. You don't have to write the 1 there, but you can. 2 minus 2 is 0. B and A stays on the bottom. We have a 0 there. Do we leave it like that? Well, what's c squared divided by c squared? That is 1. So here comes our rule. Okay? This comes our rule about anything to the 0 power. So any non-zero number, that should be c, raised to the 0 power is equal to 1. So c to the 0 power, that's just a 1. Because think about it, c squared divided by c squared is 1. So your answer is B over A. All right, the next one, example 5. See if you can do that on your own. Pause the video and try it. All right, everything has an exponent. Negative 2 is being cubed. Y to the 5th to the 3rd. That's to the 15th. Now we are all over 2xy cubed. Well, remember in your calculator, you can put in parentheses, but you'll get the same result. It's going to be negative 2 times negative 2, 4 times negative 2, which is negative 8. Y to the 15th. Look how many steps I'm doing. I notice students tend to cut corners, but if me, who's done this longer than you've been alive, is making multiple steps, then you should probably do that too, okay? 4 is going to be left. Now we deal with them. There's no other x's, so it stays in the bottom. 15 minus 3, that's going to be 12. All right. There are 3 for checking for understanding. I want you to pause the video and try your hardest. It's easy, medium, and hard. Okay, but just try your best and then play the video and see how you did. 4 minus 2 is 2. 2 minus 1 is 1. I got to bring this 4 into everything. So it's 3 to the first to the fourth, 5 to the fourth, r to the 12th, all over 4 to the fourth, p to the 12th. Okay, everything is raised to a power. Now we're going to clean it up. 3 to the fourth, that's 3 times 3, 9, times another 3 times 3, 9, which is going to be 81, m to the 20th, r to the 12th, all over 4 to the fourth, which is 256, p to the 12th. They don't have the same basis, so we're not going to subtract anything, but let's try this. 81 divided by 256. I don't feel like reducing it, so I'm just going to hit, okay, what is it as a fraction? Math, fraction, enter. Okay, that's as low as it can go. Okay, there's nothing that can be reduced. So it's going to stay 81 over 256. There's no other m's. Oh, we could have just left it like this. Can't be reduced. All right, the last one. Okay, we're going to bring a 2 in, so it's 2 squared. I'm going to bring this 2 in, so it's g to the 6th, h to the negative 4. G to the 2nd to the negative 3rd, 0 times negative 3, which is just 0. All right, there's 2 different ways we can do this. We can just straight up use subtraction like we've always done and say, okay, well, this is a 4. 6 minus 6 is 12. Negative 4 minus 0 is just negative 4. And if it's a negative exponent, that means it needs to be moved. So this stays, this goes. So subtract like normal and then move, or you could say, all right, I'm going to move these first. This is g to the 6th. This goes to the top, g to the 6th. This goes to the bottom, h to the 4th, h to the 0. And then go across. 4, g to the 12th, h to the 4th. Okay, there's different ways to do different problems in mathematics. That's the beauty of it. But you always get the same answer. All right, now you're going to complete 7-2 delta math.